Welcome to MrCScience.com's video on chemical reactions and equations. A couple videos ago we talked about changes, chemical change versus physical change. Well, we covered physical change pretty well in just a brief description and phase change. Now let's get into chemical change, which is where we're going to spend most of the rest of the module on. Chemical change is represented by chemical reactions. In a chemical reaction, the atoms and molecules are rearranged, broken down, put together differently. That denotes a chemical change. We track these by what are called chemical reaction or chemical equations. And we're going to get into chemical equations and into balancing chemical equations. Okay, so let's start with a really basic chemical equation. Across the side here, I've got my carbon atoms, my oxygen atoms, and my hydrogen atoms. So we're going to play with those a little bit. So let's take a look here. So our first chemical equation we're going to do, let me adjust my palette. There we go. Okay, our first chemical equation we're going to do is carbon plus oxygen is going to give us carbon dioxide. So we do this with molecule kits as well, but let's do it here. So if I go ahead and grab a carbon, and then I grab a couple oxygens, because we've got O2, that 2 denotes 2 oxygens, and I've already read about homonuclear diatomics, where certain atoms automatically bond with themselves to form what's called a diatomic, 2 atoms. So they make a double bond like that. So we got carbon plus oxygen gives us that, and basically everything rearranges itself. The carbon, whoops, wrong tool, missed. The carbon bonds with the 2 oxygens, so the oxygens come apart here. I could actually pull them apart if I wanted to. And we get double bonds between, working with our valence electrons. We get double bonds there. So when this is written, this is denoted as, there's a little S here, there's a little G here, and there's a little G here, all in parentheses. You'll learn, and we're going to use this a lot, S is solid. So carbon is a solid in this reaction. G, if you haven't guessed already, is gas. Oxygen and carbon dioxide in this reaction are a gas. There's other ones, L, which is a liquid, means a liquid composed only of itself, because there's another one that's a little different. AQ stands for aqueous. Aqueous means dissolved in water, so a lot of the chemistry we'll do will actually be dissolved in water, so aqueous water will be there. If we use water all by itself, just H2O, it's liquid, but if something's dissolved in water, then it's aqueous. So solid, gas, liquid, and aqueous. This is in your book. You'll want to remember these. We'll be using these going forward. Also, another term we want to get in here is reactants versus products. So the reactants are the things that react. They're what goes together usually to the left of the arrow. Products are what are produced. So we got our reactants become our products. So left side reactants, right side products. We'll talk later about how that might change a little bit, but for right now, know that your reactants versus your products. Okay, so let's do another chemical reaction, the combustion of methane. Methane's formula is CH4. So from earlier modules, we know that carbon bonds with 4 hydrogens in kind of a tetrahedral shape, or in exactly a tetrahedral shape. So 1, 2, 3, 4, 4 single bonds. And then, as we've seen many times before, oxygen is O2, a homonuclear diatomic, so 2 oxygens. So our reactants are CH4 plus O2. And this is called a combustion reaction. When we do a combustion or a complete combustion reaction, we should get out carbon dioxide and water. So let's just deal with what we got here. So if I go back and I just work with what I got, so carbon dioxide, so I need my carbon, I need my 2 oxygens from my reactants. Now go over to my product side, draw my bonds on my carbon dioxide. And then I've got left my 4 hydrogens. But what happened? I have no oxygen to bond with them. So my 4 hydrogens. So in reality, what's going on is we're going to need, here, let's do this. Control Z, beep, 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 bop, 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 bop. Okay, so in reality, what we're gonna need is we're gonna need another one of these. We're gonna need a second double bonded oxygen. So now if we grab our carbon, we grab our 2 oxygens, we double bond our oxygens to our carbon, so we make our carbon dioxide. And then we've got 2 remaining oxygens. And we've got our hydrogens. Each hydrogen will be single bonded to the oxygen. So what really happened is we needed 2 oxygens to complete this, to balance this equation so it works out correctly. Also, just so that we get in the habit of adding them, what we got is we got methane, is a gas. O2 is a gas. Carbon dioxide is a gas, and this might not seem right to you, but H2O is a gas. Water is a gas because when we burn, the heat is enough that it's changed phase from liquid to a gas, so it produces steam or gaseous form of water. So this is the beginnings of balancing an equation. And what we can do is, here, let's get rid of all this stuff out of the way. Delete, boom. So if we start here, we got one carbon and 4 hydrogens. Here we got 2 times 2 or 4 oxygens on the product side, our reactants. Then if we look over here, we've got 1 carbon, we got 2 oxygens, we created 2 waters, sorry. 2 times 2 is 4 hydrogens, and 2 times 1 is 2 oxygens. So if we add all those together, we get 1 carbon, we get 4 oxygens, and we get 4 hydrogens. Same as here, 1 carbon, 4 oxygens, 4 hydrogens. Everything balances out because, remember, matter can be created or destroyed. It can only change form. So conservation of matter occurs across here. We do not create atoms out of nowhere. We don't lose atoms or destroy atoms. So the products, so the number of atoms on the reactant side has to equal the number of atoms on the product side. Okay, let's look at another example. Your book kind of has an example. HCl, hydrochloric acid, plus calcium bromide. Br3, that should be, no, that's Br2. Sorry, my old eyes, I was like, calcium has a +2 charge, bromine has a -1. Okay, so they go through what's called a replacement or double replacement reaction, although your book doesn't talk about that. And it makes hydrogen bromide, or I wonder if that'd be hydrogen monobromide. Okay. And calcium chloride. So let's see if this equation is balanced. So on our product side, we have what? We have hydrogen, we have chlorine, we have calcium, and we have bromine. Okay, we have one hydrogen, we have one chlorine, we have one calcium, and we have two bromines. If we go over here, we've got hydrogen, we got chlorine, we got calcium, we got bromine, all the same thing. Here we got one hydrogen, we've got one bromine, we got two chlorines, and we got one calcium. Now you look, chlorine is not balanced, bromine is not balanced. We went from one chlorine, so we turned a bromine into a chlorine. Well, we can't do that, so we have to balance the equation. So let's start with what we got here. So we got one hydrogen. We got two, we have one chlorine, we got two chlorines. So that means we're going to need at least two chlorines. So we're going to put a 2 in front of that, which now gives us two hydrogens. So we're going to have a 2 there to give us two hydrogens. Now let's go to our calcium. We got one calcium. We got one calcium. Cool. We got two bromines. Now with this 2, we got two bromines. So if we redo this, now we got two hydrogens on this side. We got two chlorines on this side. We got one calcium. We got two bromines. Now if we go to this side, we got two hydrogens. We got two bromines. We got two chlorines. We got one calcium. Now everything is equal and the equation is balanced. We're going to do this a bunch of times. Maybe we'll do another example here quick. Let's do a rather complex one. Since you'll be going through your book, it'll give you some simple examples. Let's do a harder one. So let's talk about sugar. H12O6, a molecule of glucose. Our bodies take that molecule of glucose and in the presence of oxygen, burn it effectively, convert it into now combustion reaction, carbon dioxide and water. We get a bunch of energy off that, which we use to power ourselves. So let's start balancing this equation. So let's go here. We got 6 carbons. Right here, let's see what we got on this side. We got carbons, we got hydrogens, we got oxygens. On this side, we got carbons, we got hydrogens, we got oxygens. Currently, we have 6 carbons. We currently have 12 hydrogens. We currently have 6 plus 2 or 8 oxygens. Let's go to this side. We currently have 1 carbon. We currently have 2 hydrogens. And we currently have 2 plus 1 is 3 oxygens. This is not balanced. It does not work out. So let's start with our carbons. We got 6, we need 6 over here. Since there's only one molecule containing carbon, we're going to need 6 of those to balance that out. Okay, now let's go to our hydrogens. We've got 12, we need 2, or we got 12, we have 2, so we need another 6 over here, or 6 times here. So 6 times 2 is 12, we're going to have 6 in front of that. Okay, now we got 8 here on oxygens. We got 3 here, that doesn't seem very well, but let's go back and let's take a look at our difference here that we got now. So we got 6 carbons here now, so nothing's changed on this side. On this side, we've changed. We now have 6 carbons. We now have 12 hydrogens. We now have 6 times 2 is 12, plus another 6 is 18 oxygens. Okay? So now let's look at this side. To balance this, if we change this, we're going to change all those carbons and hydrogens and oxygens, and it's going to mess everything up. But this is oxygen all by itself, which is the only thing that's different here. So 18 and 8 here already, right? So if we take this out of the 18, so we got a 10 difference. So we need 10 more. Well, we got 1 times 2 is 2. So if we add another 5 more, or a total of 6, our 6 times 2 will be 12, plus our 6 here will be 18. and then our chemical equation will be balanced. We're going to be doing this a lot, so if you don't quite understand it, we're going to walk through it, but this is a concept you will need to be able to do going forward. Important. So if you have any problems with it, don't be afraid to ask questions either in class or email me at mrc@mrcscience.com. Thank you.